morning to everyone. Myself K. Kumar, Assistant Professor, Umanoda College of Engineering Technology. I am handling the lab for Biomedical Engineering, Integrated Electronics lab. So in this, I am going to do the first experiment, verification of truth table for basic logic gates. Okay, AND gate. So AND gate from a basic operation, it has two input, one output. So A and B is the input, Y is the output. The Boolean expression for this AND gate is Y equal to A dot B. So we are giving two binary multiplication of using this AND gate. So totally two inputs and one output. Here we are using the IC 7408 integrated circuit IC. So it has 14 pin number 1 to 14. So generally we are using pin number 1 and 2 is the input and 3 is the output. So in this particular IC 748 has 4 AND gate. So we are using first AND gate, the input is 1 and 2, output is 3. Similarly the second gate is input is 4 and 5, output is 6. Similarly, so for third gate, so 8 and 9 is the 9 and 10 is the input, 8 is the output. Similarly 13 and 12 is the input, 11 is the output. So additionally we have two pins, one is 7th pin is ground and 14th pin is VCC. We want to apply the power supply VCC to 14th pin and the ground signal is pin number 7. Okay, this is the truth table for AND gate. So AND gate perform the basic multiplication Y equal to A dot B. So if you give the input 0 0 means output equal to 0. If you give the input 0 1 means output also 0. Multiplication is 0, so output is 0. 1 0 means output is 0. So both inputs are 1 means the output is 1. So only in the case of both input are in 1, that is value or high means output is 1. For this experiment we are using the digital IC trainer gate. So this is our trainer gate. Using this trainer kit we are going to execute our circuit and verify the truth table. So here, so 1 to 10 is here the user input. So this is the input. So we want to apply the input to supply to the pin numbers. This is input. So we are going to see our output in this upper part. So totally in this kit 10 inputs are available, 10 output. For our requirement we are using the input pin and output pin. So I am using the separate breadboard. This is a breadboard, separate breadboard connection for this experiment. Here I am using the IC 7408. It has 14 pin. So pin number, this is pin number 1 2 3 4 5 6 7. We are giving the 7th pin is here ground and the 14th pin is here VCC power supply. So we are going to give the supply from this trainer kit. This is VCC is supplied to the 14th pin and the ground signal is supplied to the 7th pin. So this is common for all the ICs. So we are giving the plus or minus 5 volt. Here 5 volt we are applying the input for the 14th pin. So it has two input. So one with pin number 1. So we are using the wires. With the help of this wire I am going to give the input from the IC to the input port. This is input 1. So this wire connect between the IC number 2, that is input 2. So totally we have the two input. One is the pin number 1 is the one input and 2 is the output. We are going to consider this is A, this is B. So output is Y equal to A dot B, that is the multiplication is the output. So pin number 3 is the output. I am going to give the pin number 3. So pin value, input value 0 means that is the low value, input value high value means that is the 1. So we are going to do the binary multiplication for the two input with the help of this the AND gate. So I am going to verify this truth table. So here, so we are giving the input 0 0 means output equal to 0. So I am giving the power supply and trainer kit will be switched on. So supply is going to the circuit. So two input is 0 0. For example, this is input A, this is B. So both inputs are in low value, that is 0 0. So output is also 0. So input is 0 0, output is also 0. So if input is 0 1 means output also 0 with respect to our truth table, input is equal to 0 1 means output also 0. So next input is 1 0. So we want to change the input is A is 1, B is equal to 0, so output also 0. So next both the inputs are 1 means both value are high, 1 1 means output also high. So with the help of this experiment we verified the AND gate. So whenever both inputs are high value means the output is 1. So this is the operation of AND gate, just it does the multiplication operations. So next gate is OR gate. So OR gate has two input, A and B is the input, OR gate is A and B is the input, Y is the output. So it performs the addition operation, logical addition operation, Y equal to A plus B is the output. So here we are using the IC7432 pin, it also 4 pin IC. So 1 and 2 is the input, 3 is the output, similarly 4 and 5 is the input, 6 is the output, 7th pin is ground, 14th pin is another VCC. So this is truth table for OR gate. So if we give the input 0 and 0 means output also 0. So if we give the output input 0 1 means output is 1, 1 0 means output 1, 1 1 means output 1. So in this truth table, so if the values, any one value is 1 means that is value is high means output also will be high, otherwise output value is 0. So this is the implementation of verification of truth table for OR gate IC. This is IC7432. So it is 1 and 2 is the input. So input is the connected from pin number 1 to input port. This is input 1. So this is input 2. So pin number 2 to port 2 we are connected the input 2. So third pin is the output. So finally I am giving the VCC to the 14th pin. This is 14th pin VCC and 7th pin is ground. So I am going to verify the truth table. So with this circuit connections. So here both input as per the truth table. So if the both inputs are 0 0 means, so A equal to 0, so B also 0. So what about output means output also 0. So LED not glown, so output is 0. So 0 0 means output is 1. So I am going to vary the value. So 0 1. So 0 1 means input is A is 0, B equal to 1 means output is Y equal to 1. So next input is 1 0 means, so also output also high, that is 1. So finally next input is both inputs are high means output also 1. So from this experiment we verified the truth table. So 0 0 means output is 0, 0 1 means output 1, 1 0 means output 1, 1 1 means output is 1. So this is the pin diagram for NOT gate. IC7404 is the pin number. So it has 14 pin. So in this 5 NOT gate is available. So 1 is the input. So in this has only one input. A is the input, output is Y. So it provides the inversion operation. If you give the input this truth table, it gives the input is 0 means output is 1. So it inverts the input into output. So one is input is 1 means output is 0. So pin number 1 is the input, 2 is the output, 7th pin is ground, and the 14th pin is the VCC. So I am going to this implement in this trainer kit. So IC7404. So in this it has one is the input. So input 1 is in the connected from this 1 to pin number 1 to input port 1. So it has one input, one output. So output terminal is connected to the output port. So I want to verify the truth table, and VCC is given to the 14th pin, and ground signal is given to the 7th pin. So if you give the input voltage 0 means, so that is input is, so input is I am giving the input is 0, that is input is low means output is high, output is 1. So I am changing the input voltage from 0 to 1. So input is A is input is 1 means output is equal to 0. So that's why I am verified the truth table. So it provides the inversion operation. If input is 0 means output is 1, output is input is 1 means output is 0. So that's all about implementation of NOT gate using IC7404. So next gate is NAND gate. So NAND gate is the inversion of the AND gate. So if you give the input A and B, output is Y. And the Boolean expression for NAND gate is Y equal to A dot B bar. So that is, it is a inversion of the AND gate. So it is called NAND gate. Here IC7400 we are using the to verify the truth table. So here these are 14 pin input. So 1 and 2 is the input, 3 is the output, 7th pin is ground, 14 pin is VCC. So this is a truth table for NAND gate. So if you apply the low value, that is 001 means output is high. That is inversion of NAND gate. 01 means output is 1. So 10 means output is 1. 11 means output is 0. So any one of the values here the same value of input means output is 0, otherwise input is output is 1. So different conditions we want to verify the truth table. So I'm going to implement this IC7400 NOT gate in the trainer gate to verify the truth table. So it has 14 pin IC. So first pin is input. I'm giving this first pin is to the input port, and the second pin is the also inputs, given the second pin is input, and the third pin is the output. So this is connected in output port 1. So if you apply the input value 00 means as per the truth table, so input is 0, that is low value means, so output is 1. So input is 01 means output also 1. So if input is 1 and 0 means output also 1. So first three condition output is high. So next, if you apply the both values are high, 1 means output is 0. So from this implementation we verified the truth table. So 00 means output is 1, 01 means output is 1, 10 means output 1, 11 means output is 0. So truth table are verified using the digital trainer kit.